Okay, guys, take two. All right, so yesterday, which is technically still today for me, this is coming from my dining room. We looked at waves, and we, on Tuesday and Thursday of last week, we looked at the phenomenon question. Get back to it. Right, there's the phenomenon question. What makes water waves appear the way they do? And I asked you a couple times while we were in class, what do water waves have to do with elephants and ground? And I said, we're going to be bridging that soon. Well, lessons 10 and 11, which is Wednesday and Thursday's lessons, are those bridging lessons. They are the ones that bridge water waves to vibrations and ground. Okay, so our new phenomenon question is, how can ripples in water, which we've been talking about, water waves, help explain vibrations on land? And we talked about elephants and vibrations in land. So lesson 10, which is today's lesson, we'll be using a model to explore how waves transfer energy across a distance. And then lesson 11, which is Thursday's lesson, we'll be gathering information to explore how elephants detect ground vibrations. Okay. And my son and my husband are both here to try to help me through this, because I don't have a desktop, what do you call it? An Elmo. What is that?
Camera?
A desktop camera. Yes. Is that what it's called? Projection camera. I don't have one of those for my house. So we have to use the camera that's on my laptop that I have at the house in conjunction with my kitchen table and supplies I brought home to do lesson 10. And I'll go up to school tomorrow afternoon. Hold on just a minute, please. Okay, Graham will be my sub for tomorrow. Is that one mine or yours?
It's mine.
Where's mine?
Behind the computer.
Okay. All right. So you guys, before I left class on Tuesday, I showed each one of you guys my little boat. Okay. And you guys are already familiar with the wave pool. And Craig, my husband, was helpful enough to fill up this wave tank half full of water. Hey, Verona, my dog goes right here. Trying to get loving. On your page 23 in your logbook, that's where you need to be. You have a question right here. Predict how the boat, hello, Verona, and the water might move when waves are generated. Okay. Sorry, I'm going to read backwards. Remember, the word generate means to make. So if I make waves using this really fancy paddle, which you guys are very familiar with from last Thursday class, if I make waves using this really fancy paddle in this wave pool, how are the water waves and the boat going to move? How are they behave? Okay. Think about the terms that we discussed. Come here. On Tuesday. Come here. Come here. Come here, Verona. Come here. Come here. Come here. Come here. Here's Verona. Here's Verona. Hello. Okay. Word generate means to make. So amplitude. If it's a high amplitude wave and high wavelength, will the boat and the water behave differently than if it's a low amplitude and low wavelength wave? Okay, so you're going to answer that question about the boat and water, that question at the top of page 23. Okay, that's my answer. And you're going to start your answer with, I predict the plastic boat will, how's the boat going to move? Okay. Compare it to the buoy. Remember the buoy video? We watched it on Wednesday and we watched it yesterday, Tuesday. Okay, so compare the boat in the water to the buoy in the ocean water in that video. Okay. Come here. Oh, here's a Verona. See, she smiles like her mama. Hello, Cookie. Hello, jealous mama. Okay, so I'm giving you a couple minutes to answer that question. Your first sentence should answer how the plastic boat will move in relation to the water, and compare it to the buoy and the water in the video. And then with your second statement, tell me how, if we have bigger waves, meaning waves with bigger or greater amplitude, how will the boat move? Okay. Is the boat going to move way across the tank? Is it going to move not at all? How's it going to move? Okay. So you should be giving me two statements. And I'm giving you 2 minutes to do this. Thank you. And thank you for pausing your game to be here.
Also, you
No,
know,
you're
you could just
sure.
ask them to like pause the video.
I know, but I have students who don't do that well. They kind of rush. So, you know. Your foot's gross. Your foot is gross.
I'm just assuming that's dirt on her foot.
Cookie. Cook. Cook. Okay, one more minute, guys. Remember, 2 statements. One telling me how the plastic boat will move. Is it going to move across the tank? Is it going to move up and down? How's it going to move? Think about how the buoy moved in the video with the ocean waves. And then tell me if the waves have greater amplitude, how's the boat going to move? Okay. You're not Cookie. You are Verona. Hey, Cookie. Hey, Cookie. Cookie, Cookie. Come here, Cookie. Come here. Verona, behave yourself. Come here, Cookie. Come here. And here's Mom Dog. Here's Mom Dog. Verona, behave yourself. You know. Hello. And there's your sweet girl. Verona, behave yourself. Okay. All right, enough of that one. All right, so would you think the boat's going to get pushed to the other end of the tank by the waves? Would you think the boat's just going to move up and down like the buoy did in the video? Do you think the boat's going to move around in a circle like the buoy did? Do you think the bigger waves with greater amplitude are going to push the boat faster to the other side because the water's going higher? Or do you think greater amplitude is going to have nothing to do with the way the boat moves? Okay, just ideas. All right, if you need to, you can hit pause, but I'm going to go ahead with the teacher demonstration of waves transferring energy. Unfortunately, I didn't get these written on the board, and you guys know that I normally like to do launch, learn, land on the board. So this would normally be the learn part on the board. All right, so generally the way the directions go, it says have students stand in a circle around the wave tank. That would honestly be hard the way my room is set up. So this actually works better for you, the way this is going to be. All right, who wants to help with this?
With what?
I have to have someone hold this.
It was good.
Okay,
Sat
that works.
down.
Can I have that, please? I'm thirsty, please. Thank you.
You tell me that doesn't help with thirst. It makes you more thirsty.
Told you, students. Here's my sarcasm. Shocker, my child, my sense of sarcasm. Okay, so this first kind of wave is supposed to be low amplitude, short wavelength. Good luck to me getting this. And I keep on messing this kind of wave up. Okay. Unfortunately, we see the water is still moving over here. All right, now it looks like I'm finally getting it right. The boat, while it does go across the tank, it doesn't scoop right on over there. And truly, if I were doing it like I'm supposed to, these aren't great big tidal waves. These are small waves, low amplitude, low wavelength. The boat's not going across the tank. Okay. I'm gonna guess that all my students thought this boat was gonna go right on across the tank, and it didn't. Kind of staying in the same place. If anything, it's kind of maybe going around in a circle. And if this were at a great big old lake or ocean, it would be acting like the buoy. It doesn't need to be anchored. And honestly, I don't know that buoy in the video was anchored. I remember we said things.
Becoming the Titanic.
It is becoming the Titanic. Thank you, Colby. These are bigger waves. Can you pull that towards? Thank you, Colby. We've got one over there. Bigger waves makes the water do what? Want to answer for us, Colby? What's happening to the water?
It's trying to get out. That's what it's trying to do.
It is trying to get out. So it's coming right on it over the edge, isn't it? And the boat tries to go out with it, doesn't it?
And it's also sunk.
It became the Titanic too, didn't it? Okay, so low amplitude, short wavelength waves, the boat doesn't go anywhere like this. See how it's trying to stay with the paddle? But high amplitude, I'm going to keep sinking this boat. High amplitude, long wavelength waves. Can you talk to Adrian? Preferably outside the room. High amplitude waves, Miss Vandiver sinks the boat. Splashes some water outside the tub. Gets herself wet. Continues to get the table soaked. And the boat moves on down the tank. Okay, so. All right. I'm having a great time dropping everything. All right, can you hand me those notebooks? All right, can you hand me what I just dropped on the floor? I've soaked the table. Oh, would you mind getting paper towel over there? Because I drenched that area of the table.
Getting it?
Well, trying to absorb up some of that water.
Well, we're gonna just have to take the tablecloth off. That's
Tell your dad
already
that Mila can come over here in a
absorbed.
few minutes because I'll be done in a matter of minutes. Oh God, I got this all wet. Okay, so so the way we can make the the way we can make the boat move in the direction of the wave is push the paddle harder and faster, which is what I did. That's how I made the boat move. You see my sloth back there. You guys have asked me what my favorite animal before is. You see my sloth back there, along with our games. So when I pushed the paddle harder and faster, we had higher amplitude waves and we had larger wavelength, longer wavelength, right? And that made the boat move in the direction of the wave. So if I wanted the wave to come towards me, I pulled the paddle towards me, then the boat came towards me because I'm giving it longer wavelength and more amplitude. And I use more force too. Trying to read all the other questions. When I had low amplitude, in other words, I didn't put much force in that paddle, the boat really didn't go anywhere. We're not in a circle. Okay. Which is like the buoy we saw in the ocean. So what revealed about how waves affected a boat's motion? Waves can make the boat move up and down when they pass, but they don't actually move the boat to the other side of the tank. Oh, I got this soaked. With the help of the boat, what can we infer about the motion of the water when waves pass? The water is also just moving up and down when the wave passes. Okay, so we're going to write some of these observations down. And I'm going to do them in bulleted points, and you guys can straight up copy what, oh, this is wet, what I've written. It's like I have a tablecloth on my table at school. I have a tablecloth on my table here. The tablecloth at home is just nicer.
And never here really.
What?
And never really on the table.
Yes, only here on the table when Colby puts it here because Colby makes it look nicer. Okay, so some observations. Okay, Verona, I love you. I do.
Verona.
Thank you. Waves can make the boat move up and down when they pass. You want to go see what's up with Adrian, Colby? But they don't actually move the boat. Does he want to bring Mila over? To the other side of the tank. What's up then?
Tell you later.
Okay. The water is also just moving up and down when the wave passes. we can see that the wave makes the water move. Motion is an indicator of energy. We learned this in module 2. The wave has energy. Because B/C means because it makes the boat move up and down when it passes. Okay. Okay, there's another thing to add on to this. There's quite a bit in lesson 10, and it's not all going to fit on this box. So you're going to have to record all this here, but you're also going to have to turn to the back of the page to continue recording stuff. I know it's a lot, and I'm not there, but I expect you to write this. It's straight copying, guys, and you will need these points when I get to testing you. Okay, I don't know what to tell you. You've seen my tests. They're hard. There's a lot of information to them. So you need all this information. Did you notice the sounds that were created with the boat and with the water? I hope you did. I heard a sound when the water hit the side of the tank, when the wave. That collision made the water splash some. The collision of the water hitting the side of the tank. Thank you, Colby. Yes, sir. So the next question is, how can we use our understanding of energy to explain how the wave is causing motion as it travels? Sorry about that. And we started to talk about this a little bit yesterday. We talked about energy transfers. So when the wave is moving, energy is moving, right? Energy is moving water up and down as it goes from one side of the tank to the other. Okay, so my book gives that to me as 2 bulleted points. I'm going to combine those as 1. Okay. When the wave moves, energy is moving. When the wave moves, Energy is moving water, the water, up and down as it goes from one side of the tank so it goes from one side of the tank to the other. Sorry. Craig?
Yeah.
Come here, please. What was it?
I'll tell you in a minute.
They don't want to bring them over
Not right now. Not right now.
today.
Mm-mm. I'll tell you when I get there.
Everything okay?
Yeah.
Can I have my phone? Okay, at this point, if this is not enough time to write all this down, then you need to hit pause and continue writing. Okay. All right. There's a few more things. All right. In the classroom before I left yesterday afternoon, technically today, this afternoon, before I went to the neurologist, I updated the class model. Not the one that has the pictures of the elephants, but the one that had all the words on it, the one that had the waves, and the one that had lots and lots of words on it. I updated those two before I left, and I took pictures of them. There was some information that we were supposed to come up with together before I updated those. Obviously, I couldn't teach the lesson before I updated those because that would require me being with you on Wednesday together before I left. It's just now Tuesday night, so that wasn't possible. So we're going to put that information on the back of page 23. Okay. I'm going to grade your work. I'm thinking Friday when I come back to class, because my doctor's asked me to stay out Wednesday and Thursday and see if I can knock out this migraine. Because today, Tuesday night, this is day 21 of this migraine. She gave me my nerve blocks, and right now I barely have a migraine at all, which is wonderful. Okay. I want to come back Friday feeling good for my students. Okay. And I'm thankful that the two lessons that I have, which is Thursday's lessons, are ones that are pretty good for teaching remotely, ones that are good for teaching from a computer. They work for you and for me, okay? So it means you have a lot of copying, but you get a lot of easy points for copying. I need you to work diligently, okay? I know I've got students who've been working really hard for me. First and second block, you've been really good about doing your work for me. Third block, I need you to do your work like you're supposed to. Do you understand me, third block? As soon as I get done with this class, I'm calling some parents to make sure this gets done right, okay? Mr. Graham should be subbing for me on Wednesday and Mr. Thomas on Thursday. Okay, I need you to do your work. Because if not, you're not going to be ready for the quiz that I'm going to give you Friday. Because I want to make sure you've done what you're supposed to do. So I'm just throwing a little pop quiz in on you on Friday. All right, do your stuff. So we have a few more things that you're going to write on the back of page 23. So we found evidence that waves transfer energy, but waves do not transfer matter, because a boat did not move across the wave tank when we used small amplitude, the little short waves with short wavelength. Would this apply to another object placed in the wave tank? So let's say I dropped a cork in there. I got to find a cork, and I meant to bring home a not a golf ball, one of those little racquetball balls. But the teacher book did not tell me to do that. And I didn't read through all the small details before I left the classroom today, so I didn't know I needed to bring that home. So right now I'm looking real quick for a cork. Craig, do you know where a cork is?
What, for the plastic container?
Cork, just a cork. A floating cork. A floating cork right now. Video going right now. And if I were in my class, I know exactly where to go get something, but I'm not in my class. It's frustrating because I had a bunch of these in my classroom, but it didn't call for me to grab any.
Hello there, it's morning time. Yeah.
Guys, now I know why you gave me all those little balls without giving me a reason to have them. Oops, sorry. So much. Thank you, thank you, thank you, thank you. Okay, Mr. Craig came to the rescue. Okay, so if we float a cork in the in the tub of water, in the wave pool, would that move across the tank? What do you think? With short amplitude, meaning not tall waves, but little short waves. Well, let's try. Craig, can you come hold the computer? And let's try to not get it all over this. No, can't see it. No, 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 you got. So is this cord going over the other side, or is it just kind of staying in place? You see, it's just kind of staying in one place. So it's doing the same thing as a boat. You would think it's anchored in place, but it's not. It's doing the same thing as the boat. See, we have these short amplitude, short wavelength waves. It's really not going anywhere. Okay, thank you. Okay, put it down. What if we tried this with a different liquid? What if I were to use water or milk in here instead of, I mean, not water, milk. What if I were to use milk or juice instead of water? I'm not going to. I'm not using 10 liters of milk or 10 liters of juice. That'd be a very expensive experiment. In my classroom, I do have a couple little density, call them toys, but little density tools that I can show you Friday that will show you the same premise, the same idea. Okay. So it doesn't matter what liquid you're using, they're going to behave the same way. Okay. So there's a couple things we can add to the back of page 23. No matter what floating, I'm going to put device, I'm going to put in parentheses cork or boat or ball that we use in the wave tank the device would still not move across the tank when using low amplitude, short wavelength waves. Here's a statement. Okay. Okay. Thank you so much, Colby. Okay. And then the other question, if we're using a different liquid, such as juice or milk, still going to behave the same way. Any liquid waves in any liquid behave the same. So our summary, and I'm going to put stars in front of this, like the asterisk kind of stars. Waves transfer energy without transferring matter. That is why the boat didn't move. That is why the cork didn't move. Okay. Let me do that. So if you notice, both the model that has a picture of the boat, and it didn't have a boat on it yesterday, but the model that has a picture of the boat and, well, let me show you that. It looks a little something like this. And of course, it's being funny. Okay, that is in the front of the classroom. Okay, that's already added to the picture. I added that at the end in my third block yesterday. And I already added the extra words to it. Okay, it's in the front of the class on the whiteboard. I didn't have a chance to update all the words for lesson 10, but the drawing for this model is already updated for you. See the boat? See how I have the arrows that show how the boat is just kind of bouncing along in place. It's not going anywhere. The words got updated. It shows energy transfer is going in the direction that the wave is moving. And then the words that got added, waves transfer energy, but they do not transfer matter. This explains why an object moves up and down or side to side when waves pass, but stays in about the same spot. Okay. If you need more time with this, hit pause on the video. Okay, so now we have a new picture to stare at. This and 10. Okay. This a picture. Beach cross section. Think about the types of water waves you've seen before. I know not all of you have been to the beach, but a lot of you have. Do your observations from the demonstration match your experience with water waves? When you've been floating in the water, have you felt waves move you up and down? Or did you think that our demonstration did not match your observations because you've seen seaweed get pushed onto the shore? Or you've seen surfers get pushed by waves, so you think that that is a reason why it doesn't match our demonstrations in class? Okay, so waves seem to behave differently as they approach the beach than they do when they're out in the ocean. You ever notice that? So what's the difference between a wave tank and the beach? Look at the bottom of this. Bottom. Chloe said hi. got long hair. It looks like his mama. Okay, look at the bottom of that. Okay, it's flat, isn't it? Right? Can you hand me the paint pan, Colby? Versus this. This paint pan has a bottom more like a beach. Look at the bottom of this. That is not flat. That is more like a beach. How's that different? I'd rather be there right now. Wouldn't you?
It's on tinfoil.
Not on tinfoil. Florida would be nice though, right?
The space station
Space station first.
doesn't look like
Space
beach
station.
to me.
How is it like a beach though, Colby? Since you're my current only student around, how is that like on the face?
Water, sand.
Thank you, because the sand is what?
It's going down.
Going down towards the,
Water.
which is,
Waves.
but it is overall
Water.
deeper. You want me to fling some water at you?
okay.
Would that help you? If I flung some water at
I
you?
want to fling some water at you. That's the case.
I can just fling some Dr. Pepper at you. Oh, you got more of it. Never mind. Never mind. I'll scratch that. Told you. He's like me. Sorry. Okay, so the wave tank has a flat bottom. So deep ocean, relatively flat bottom. Beach, not a flat bottom. I like being the star of Zoom. Do you like?
What about Cookie and Brian? Aren't they the star of Zoom?
Oh, you want to put Cookie up there in front of you? You'd have Cookie up there. I see a Verona. She's right there. Okay, so the wave tank's flat on the bottom. The ocean floor can be slanted. At the beach, the water gets deeper as you go farther away from the shore, right? I mean, personally, I like being out there where it's a little deeper. 10, 12 feet, 15 feet. That's more fun. That's where you get out there with the sharks. And it is way fun swimming with the sharks. I mean, I like chasing after the 8-foot sharks. Oh, there's a newborn baby. She's so little. She's grabbing the tablecloth. That wasn't a very nice newborn baby. Oh, you're running her into the TV.
No.
Here's your baby. Cookie, say hi. Cookie Wookie. Cookie Wookie. Hi, Cookie. Hi, Cookie. Oh, I know how to get your attention, Cookie. Okay, Verona, you gotta move. Not yours. Not yours. Verona, move. Verona, stop. Ooh, cheese ball. Cheese ball. Cheese ball. Cheese ball. We'll work for cheese ball. Oh, you don't like cheese balls. Who do you think you're fooling? You don't work for cheese balls. We'll work for cork. Will you work for a cork?
She will eat that.
Yeah, 'cause she thinks it's a cheese ball. Not a cheese ball. That's a cork.
Trying not to.
Yeah, not food. Hey, Cookie. Hey, Cookie. I got a bunch of students who want you, Cookie. Okay, so this is supposed to represent the beach. This is supposed to be the part that you're running in. Colby says running on the aluminum foil, that part with the sun would feel great on your feet, especially as your feet were cooking in the sun.
On the aluminum?
On the aluminum, it'd feel wonderful, right?
It would burn you.
It would burn you, really?
Yeah.
Huh. Well, I would let Colby and Ian and every child that I teach go first, right?
Yeah.
Okay. Oh, okay. Anything to go on a field trip, right?
I suppose. I never get them.
You never get field trips? No child's got a field trip in 2018.
I haven't gotten them in middle school.
You did? You got to go on all kinds of them at Norton. Okay.
No, I
So-
went to 2.
What?
I just went to 2 at the art.
Okay, so a little bit of cheese ball in there. Here, Cookie. There you go. Up your nose. There you go. Good girl. Okay, so beach slanted. This would be the part you're running on. Hopefully it's covered by sand and not just aluminum. And then this would be the part with water. Okay, so at the beach, the water gets deeper as you go away from the shore. The bottom of the ocean is kind of like a pool that slants down at the deep end. So like our in-ground pool back there, that looks so awful right now. Shallow end would be where the sand is, or in our end, it'd be where it's dry. And the deep end would be where the water is, or in our pool's area, it'd be where the snakes are, right? So this is an ecosystem. How can we modify the wave pool? I'm sorry. How can we modify the wave tank? Please stop licking my hand, Verona. That's gross. Thank you. How can we modify? How do we modify? Oh, Verona, you want attention too. How can we modify the wave tank to model the slant of the ocean floor where it meets the shore? So, sorry, I've got 50 pounds of dog on me. Can we do maybe this to make it slanted? Would that make it more like the beach? So that this is the shallow end. This is the shallow end here, and that's the deep end. So this is the beach area. So the water is shallower, and that's the deeper ocean end where all the sharks and where I throw my kids
At the beach.
at the beach. Yeah.
There's gonna be sharks at the beach.
Well, yeah. You don't remember seeing the videos that people took?
They don't show up at the beaches because they're too short.
You
They're like
don't
too
remember
short.
Panama City Beach and the pictures that I took when I was up there doing
I'm talking
parasailing?
about like great whites.
Not those. Blackfin.
We got smaller ones can go.
Okay, so we could put something on one end to make this end be shallower and the other end be deeper, and that would make it more like a beach, right? Sound reasonable? Does that sound reasonable, Cookie Wookie? Does that sound reasonable, sweet girl? Okay. It says here, whatever we put in the wave tank should be heavy so that it stays at the bottom. We could put a ramp at the bottom. So I guess if this were narrower, we could put this inside there, but alas, this paint pan is wider than the wave tank. So that would be a big, no. So it says we could use a metal paint tray to create a slope. It says this should fit in there. No,
That's a good
that, no, it doesn't fit. Doesn't fit at all, does it? Nope. That certainly doesn't fit at all.
You can use your imagination to pretend it fits.
Yeah, what he said. So use your imagination that this is inside here that fits in there, because yeah, it's not fitting. Hey, Craig, don't come in here. You're on camera. Craig,
What?
do you have a slightly smaller paint tray?
No.
Because I'm supposed to have a paint tray that fits inside this wave. This ain't gonna work. Okay, guys, as Colby said, use your imagination that this fits inside here, because no, it's not fitting. No matter what I do, I can turn it diagonal. Hey, Ian, do you know of a paint tray that's slightly smaller than this one? Child, mine? Do you know of a paint tray that's slightly smaller than this one? No? Oh, well, we don't have a paint tray that's smaller. Okay, so it's supposed to be that this goes inside here and the boat only moves up and down when it's in the deeper part of the wave tank, but it moves as the same direction as a wave when it's on the slanted part. The boat doesn't move forward with the wave until it's closer to the shallow water. And water also moves in the direction of the water near the beach. That reminds me of when I've seen water waves on the beach. So we will add these things that we're having to use our imagination on to our notes. And when I come back Friday, we'll try it with the big, Colby, can you pick this up and move it that way? Don't spill. Can you move that down there? Thank you. Thank you. Thank you. Thank you. Thank you. Some more. Oh, I got some water on my computer. That's so not good. Fantastico. Not really. Okay, so we shall add some things to this notebook of ours. The boat only moves up and down when it's in the deeper part of the wave tank. But it moves in the same direction as a wave when it's on the slanted part. The boat doesn't move forward. With the wave until it's closer to the shallow water. Okay.
I think there's a Bigfoot site. Those right behind you.
I thought so too. I don't know if my kids saw it on screen though.
That's Bigfoot won't be caught.
Craig?
Yeah.
Seriously?
How's Ian? Yeah, I recognized it.
Why are you down there?
So the slant of the ocean floor changes the way the water waves behave near the beach. That's our takeaway from this part of the lesson. Okay, so if you go to the beach, you've probably observed that when you're close to the ocean shore, the water waves behave differently. And generally, when you're at the beach, you're close to the shore because you have a continental shelf. Deep ocean will be 100 feet deep, 100 miles deep. Close to shore is going to be 50 feet deep. That's shallow. Okay. So the wave model, I already updated for you in the class. Looks like this. Okay. It's already updated for you in front of the class. I just did not add this little part right here. I did put that boat in the front. I didn't put that little part in this little part. Okay. I need to add that little part when I come back Friday. And actually, I'm going to come up to school tomorrow after school and add that. Okay. And that's to show the shallow part. Okay. I'll add that tomorrow after school. Right, because I've got to grab some stuff out of the classroom. So the slanted ocean floor by the beach causes matter to move in the direction of the wave. All right. The anchor chart I also updated. That's also on the front board. Waves moving across deep water move matter up and down or back and forth, but do not cause matter to move in the same direction as the wave. And waves transfer energy across a distance. Now is the part where we connect all this information about water back to vibrations on land. Think back. What part of an elephant do they use to detect vibrations? Colby might have just given you a hint by moving the chair across the floor. I don't know if you can hear my dog, but Cookie's little feet are moving across the floor. I just gave you a great big hint. Cookie moved the chair. It made noise. And what is noise? Noise is sound. So sound is what? We've talked about this before. Sound is Tell me, Colby, what is sound?
Vibration.
Thank you. Sound is vibration. So our dog is picking up vibrations same as an elephant through her
Pause.
Yeah, for an elephant it'd be through their feet. Okay. So the elephant's picking up vibrations through its feet, and the elephant also picks it up through something that a dog doesn't have, its trunk. So generally dogs are not going to put their nose to the ground to pick up vibrations through their nose. But elephants, we know, do put their trunks to the ground to pick up vibrations through their nose. Okay. So how can we as humans pick up vibrations in the floor? Now think back when you had to play a trust game and sit on the floor. What day was that? Was that Wednesday, Thursday? You had to sit on the floor and Miss Vandiver had to stomp her foot on the floor like a petulant little irritated toddler and hurt her legs. How did you pick up vibrations on the floor? Remember I told you close your eyes. How did you pick up the vibrations? You weren't barefoot, so you picked them up through your lama, your hands. Okay. You felt the vibrations with your fingers, with your palms. Your hands shook slightly when I stopped. And your body might have even picked it up. Remember, we said that you felt the vibrations first enter through your hands, and then it went up your arms, and you could feel it in your shoulders, and you probably felt it go through your body. Okay. And I've told you guys this before because my body is more sensitive to it, and so is Colby's, because we have migraines. So we really pick up vibrations. So when we're talking loudly, he and I both, we really pick up vibrations through our head. I'm sure you've noticed that, Cub, right? When you're talking loudly, You feel the vibration through your head, like a lot, right? So you guys, you know, when you hear your voice that's recorded, it sounds very different than when you hear yourself talking. And that's because you hear yourself talk, you're hearing yourself vibrate through your own bones in your head, and you're hearing yourself through your ears. But if you hear it recorded, like through your phone or through the computer, then you're only hearing it through the air. So if you're hearing it through bones, it sounds different than if you're only hearing it through the air. Okay. Where did energy and the vibration, like when I was stomping on the floor like a petulant, irritated little 2-year-old, like Mila, where did the energy and the vibration come from? Did it come from Mr. Woods going down the hallway? Or did it come from, hi, me? And coming through my leg meant it came from chemical energy transfer from the food and drink that I drank. Cheers, Dr. Pepper. Chemical energy, right? So the energy came from me when I stomped on the floor. The energy transferred through the floor to your hand. And the energy came from energy transfers in my body from the energy that I just consumed. And that day it came from the energy that I had for lunch, from food and drinks. Okay. So energy is transferred through the floor to your hands. Going back to that big essential question, the one that's written up on my LED board. How do elephants sense rainstorms from more than 100 miles away? What do we still need to know about how elephants sense vibrations? We still are missing some information. Do we know all about all their sensory structures yet? Have we really learned all about their ears yet? Have we really learned all about their eyes yet? We haven't actually looked at their actual sensory structures yet, have we? We've studied water, we studied vibrations and ground, but we've not actually studied sound waves. We've not studied their eyes. We don't know whether they use different sensory receptors than we do. And maybe their sensory structures are different than ours. So we're going to tomorrow get more information from the book, The Elephant Scientist, the one that we already read from. And we're going to learn more information about it. Okay. Bye, guys. Check all your work from the back of page 23 and the front of page 23. A lot of writing, a whole lot of writing for 15 points. Get it all done. Okay. I'll check all it Friday. That's a lot of points. Get it all done. All right. If you need to, go back and pause in the video for it. And if you don't get it all done in class, you know you can do this for homework. Bye, guys.